Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about derivatives of e to the x, or derivatives that involve e to the x. What is the derivative of e to the x? Well, it is simply e to the x. And if you have e raised to a function, you have to think chain rule. I have a composite. I need to multiply by the derivative out front. So very simply, the derivative of e to the x is e to the x, but if you have a function that is inside the exponent, just rewrite the function e to the 2x minus 1. And what is the derivative of the exponent? The derivative of the exponent here is 2. So your answer is 2 e to the 2x minus 1. Same thing on this next problem to the right. Rewrite the exponential, e to the x squared. What's the derivative of x squared? Multiply by 2x. And that is your derivative of e to the x squared. Let's keep going here. It's the same kind of idea. We're just doing chain rules here. If I take the derivative of e to the 2 over x, you would write e to the 2 divided by x power. And the derivative of 2 over x is like taking the derivative of 2x to the negative 1, which would be negative 2x to the negative 2. So this would be my derivative. If I wrote it as one fraction, it would be negative 2e to the 2 over x power divided by x squared. Either one of those would be correct. And one more, let's throw a little bit of trig in here. You know we love our trig. What's the derivative of e to a power? You rewrite e to that power, e to the sine of x. Now what's the derivative of the power? What's the derivative of the exponent? It's cosine of x. Okay, so you can write it this way too. You can write it e to the sine of x times cosine of x. Either one of those is absolutely fine. I usually like to put my derivative up front. But that's how you take the derivative of e raised to a power. You got to think chain rule. Now, what if I gave you a problem that involves a product? This problem right here, the derivative of y is y prime. And notice this is two functions multiplied together. So the derivative of the first function is 6x to the fifth times the second function, which is e to the x. Product rule is plus. You take the first function, which is x to the sixth, and you multiply by the derivative of the second function, which in this case is just e to the x. There is my derivative using a product rule. Now, what if I threw a quotient rule at you? And I also threw some different variables in here. So we're actually taking the derivative of r with respect to w. So the derivative of r with respect to w would be the derivative of the top, which would be 4e to the w, times the bottom, which is 9w. Quotient rule is minus the top, which is 4e to the w, times the derivative of the bottom, which is 9, all over the bottom squared, which would be 81w squared. Now, I am going to have to reduce this. Everything is divisible by 9, so let's cancel out some 9s here. 9's gone here, 9 is gone here, and I cancel a 9 from here. I'd be left with 9. And I'm going to get basically 4e to the w times w minus 4e to the w all over 9w squared. There is my derivative of r in terms of w. Okay? We've got a few more problems here at the bottom just to throw you some other things. You know we do product rule. We do quotient rule. Well, let's do chain rule. Chain rule would involve taking y prime equals, what's the derivative of cosine? The derivative of cosine would be negative sine, and the inside I would leave this e to the negative 3 theta squared alone. But now I have to multiply by the derivative of the inside. What's the derivative of an exponential? You multiply by the exponential, but then you also have to multiply by the derivative of the exponent, which in this case would be negative 6 theta. So if I write this all out, I've got negative 6 theta times that e to the negative 3 theta squared times sine of e to the negative 3 theta squared. And here's the thing, I have a negative there, which I already wrote, but there's also a negative here, so those negatives would cancel and make this a positive. There is my derivative using a chain rule. In fact, this was essentially 3 functions. It was cosine, it was e to a power, and it was the polynomial. This was basically like f of g of h of x. Now, we're going to do some higher order derivatives here. What if I asked you to find just the first derivative of this function, y equals e to the x to the fourth plus 5x squared? Well, the derivative of e to the x to the fourth, we would rewrite the exponential, and I'd have to multiply by the derivative of the exponent, which would be 4x cubed, plus the derivative of 5x squared. That's easy. That's just a power rule. That would end up being 10x. Now, to find the second derivative, I'm going to have to do a product rule here. I'm going to have to take the derivative of 4x cubed, which is 12x squared, times that e to the x to the fourth. I'm going to have to add the 4x cubed times the derivative of e to the x to the fourth, which we know from the previous step is 4x cubed e to the x to the fourth. And then the derivative of 10x, well, that's just 10. And if I do some simplifying here, I've got 12x squared e to the x to the fourth plus 16x to the sixth e raised to the x to the fourth plus 10. That is an ugly derivative. But we got the job done. Now, one more. Think about this. If you've watched my videos, you know there's kind of a progression to everything. If you know we did product rule, we did quotient rule, we did chain rule, we did higher order derivatives, and we did implicit differentiation. So let's take a look at this problem. It has x's and y's. How do I take the derivative of this? Well, the derivative of an exponential is rewrite the exponential, multiply by the derivative of the exponent. That was easy. The other side, what's the derivative of sine? The derivative of sine is cosine of x plus 4y, but then I have to multiply by the derivative of the inside function, which is 1 plus 4y prime. And what I want to do here is I want to make sure that I'm solving for y prime. Well, first thing I'm going to do, I'm going to get rid of this cosine by dividing by it. And if I divide by cosine, what happens is I can rewrite that as secant of x plus 4y on the other side. So how am I going to solve for y prime now? I'm going to take that other side, 4e to the 4x, secant of x plus 4y. I have to subtract that 1, and then I have to divide the whole thing by 4. And look at that, I've got my first derivative of y. So you notice now I can throw this e to the x in with all of my other derivatives, and anything I've ever done with derivatives now I can use e to the x as well. If you like this video, please hit like. Would love it if you subscribe to my channel. I'll be posting more videos later on.